All right, so now let's look at some homework from 14.1. So the first few problems are actually straight from the homework. I'm sorry, straight from like notes and definitions. So I'm actually going to jump to one of the more interesting ones that's probably going to give you a little trouble. And it gave me a little trouble only because of the way it's worded. So I'm going to start with 14. So number 14, it wants us to explain why the two figures show equivalent graphs. So we know that these two are equivalent, meaning they have each of these vertices have edges that connect the same way. So C goes to H, C goes to H, H goes to R, N goes to C, and N goes to C, C goes to R. Okay, so that's what that means. But what is tricky about this one is this is asking for why are they equivalent, not which are true. So why are these graphs equivalent? Not what is true. Okay? That's what it's asking. And so be careful there because it's easy to make a mistake on this. Part A, or option A rather, the graphs have the same number of edges. Yes, that has to be true for equivalent graphs. Now this is the one that threw me off. It may throw you off. The graphs have the same number of edges that matches the number of vertices. So that is true. These both have 1, 2, 3, 4 edges and 1, 2, 3, 4 vertices, but that's not what makes them equivalent. Okay, so not B. C, the vertices are connected in the same way. Yes, that is important for equivalence. C goes H, C goes H, H goes to R, H goes to R, C goes to N, C goes to N. I think the last one, C goes to R. Anyway, so that makes it equivalent. And then the part D, the graphs have the same number of vertices that is important for equivalence. Okay, so A, C, D. In fact, you'll have the same 4 options, maybe in a different order. Yours will be those options. Not the letters, but like these, what the options say. Right. I didn't have it circled, but let's do 16. All right. So number 16, it is a little hard to read on mine. I tried to highlight that. I don't think it's showing up. It says using vertices to represent the land masses and edges to represent bridges. Which graph models the layout of the city? And you have these 2 options. So I think what I'm going to do is I'm going to, because I know you can't see the copy that well, I'm going to draw out a very basic representation of that using, some basic shapes. All right, so this is the North Gothinsville. Okay, so that's North landmass. So I'm going to call that in. And then this in South landmass. And then here, they actually label these islands A, B, C. A, B, C. And there are bridges from A to the North Shore, B to the North Shore, C to the North Shore, A to S, B to S, C to S. And A to B, and B to C. So I think this shows up a little better than the picture. But further, we actually want to create a graph, more simplistic view of that. Okay, so what I'm going to do is I'm going to use some dots. Okay? All the dots will represent the land masses. So that is what we're trying to get to. All right. So if I start at any part, so let's say I go from A. So A to N. A can also go to S. A can go to B. Let's go to B. All right, B could go to N. I guess I kind of went in the water there, but you get it. There's my bridge. B can go to S, and B can go to C. And then C could go to N, and C could go to S. All right, so if I pick that graph up, basically, if I was able to remove the picture except for the red lines and the green points, then I would end up with this. Okay, so I'm going to label this as N, S, A, B, C. And these lines could be curved, they could be straight. I'm going to make them slightly curved. Okay, so this, I could even make it more straightforward or more simplistic, and you can see it looks like this first option. Okay, and what we're really looking for is that it has the same connections. N goes to A goes to S, S goes to C, A to B, B to C. Okay, so that is how we would look at that. You may not even have to draw it all out, but it kind of helps. Let's do one more for our video here, and then we'll end this video. So number 20. Number 20 here. Let's see, you got a diagram. On the right is a floor plan letting vertices represent the room. Outside edges represent the connecting doors. And basically it wants to know what graph represents the floor plan. So I'm going to write on this. I'm going to put, let's put some points in each room. And what this will do is allow us to kind of keep up with which rooms we're in. And it also implies that G is the outside. So I'll put a point out there. All right, so A can go here to G. A can go here to D. Now D can only go to E. E can go to B. Now, can E go anywhere else? It's got this open door, which means it actually can go outside. What's a little tricky, there's the point outside, and that represents any outside. And then let's see, B can go outside, so let's line it up there. B can go to C. C can go to F. F can go outside. Okay. So let's see here. Can I make that any simpler? I'm going to see if I can make that any simpler so I can choose the right graph. All right. So A, B, C, D, E, F. And G can go anywhere, but I'm going to put it right up here. And to make it a little simpler, I'm going to use straight lines instead of all these weird curves. All right, so A went to G, and A went to D, and D, let's see, A can't go anywhere else. D went to E, and that's it. E went to B, and E also could go to G. Now, E went to G, so I am going to do this curve around that. The only way to get from E to F is to go through B to C, and that, and then of course F can also go to G. So, which of these looks like that? Well, that's not a bad representation. This was just, I wasn't looking at the options, I was just drawing it out. But I want to make sure, because I could twist and orient this differently. Let's make sure everything connects the right way. D, A, G, E, B, G, C, F. Notice EF doesn't connect here. It doesn't connect there. But yeah, looks like the first option there is correct. All right, so is that our third problem? It's probably getting to be a bit of a long video. Yeah. So let's end the video there. We're going to continue. There's lots of problems in this homework assignment.